Today we will make MS medium, that is from the ready-made source, and this pouch is available from High Media. Ready-made Murashige and Skoog medium that was formulated in the year 1962 by Murashige and Skoog. That is why it is also known as Murashige and Skoog medium, and in short it is popularly known as Murashige, Skoog or MS medium. This medium is a complete food with all the essential nutrients for the growth and development of plants. So it is containing all vitamins, sucrose, even gel also. And next it is mentioned as without calcium chloride. So if calcium chloride is there, it may precipitate while boiling. So calcium chloride we have to add extra. Other all things are included here. Hormones are not at all part of the medium. So hormones, plant growth regulators we have to add extra. So this is sufficient for 1 liter of medium. This is pouch is available from High Media. We have to cut it, and that entire content must be taken out with help of distilled water. So generally we used to dissolve in around 800 to 850 ml of distilled water. As this is not containing calcium chloride, so calcium chloride solution already ready-made we have with us. We only made. That is part of actually Skoog D. I'll explain you later on when we'll make the medium by making the stocks. So Skoog D is actually calcium chloride. So calcium chloride will add extra. So this is the media content. In that we are adding water, distilled water actually. Normal distilled water, not double distilled. That will work. So it's around 700 ml. Distilled water, shake it well. So total volume we will make it up to 1 liter. So that will be MS medium in liquid. Liquid MS medium, 1 liter will be ready. Shake well before adding calcium chloride. Sometimes it may precipitate, and then per liter as per stock quantity we have to add around, not around, exactly 5 ml. So 5 ml calcium chloride we have to add in this, because it is not part of the ready-made medium. The medium which we are making today is 1 liter of medium, that is containing 1 milligram per liter of BAP and 0.15 milligram per liter IAA. BAP is 6 benzyl aminopyrin and IAA is 1 oxine, indole 3 acetic acid. Here it is that addition of 5 ml of calcium chloride solution in the ready-made MS medium. So now it is a complete MS medium. So this is after making up to 1 liter, it is a complete MS medium only. After that we have to add plant growth regulators, and we will go for pH making, pH adjustment of pH. So addition of 1 milligram, that is actually 1 ml of benzyl aminopyrin, this is 1 cytokinin. So finally, by addition of additional distilled water, we have to make up to 1 liter and shake it well. This is a complete MS medium, that is ready-made MS medium. We need not to do much things, because it is available in the powder form. We have to dissolve it, and after addition of calcium chloride, liquid MS medium is ready. Now since it is having gel and we want to make semi-solid medium, gel is already present in the medium, this powder itself. So we have to boil it. After boiling we will go for pH adjustment. So this is oven here, sorry, induction heater. This is the utensil, any steel utensil we can use to boil it. So addition of the medium, liquid medium, that is containing gel. Gel means agar agar. Now we'll boil it. Alright. Right. When it's over, just bring it there. Right? So this is for pH adjustment of the medium. This is our pH meter, that is a digital type of pH meter. This is called as electrode of the pH meter, and we have to spin the medium with magnetic stirrer. This is called as magnetic stirrer, and magnetic bead is there inside the medium. So bead and this stirrer we are using for homogenization of the medium. So now, as of now, without addition of any kind of alkali or acidic solution, pH it is showing as 5.08. So for MS medium, for proper solidification of the medium, we need to adjust this pH to 5.8, not more than 5.8 and not less than that. So here it is showing 5.08. It means we have to add alkali solution here to make this medium 5.8 at the place of 5.08. Alkali solution is here, it's available as this is NaOH solution is there, one normal solution it is. So by addition of this drop by drop, and since homogenization is already going on, mixing is going on, we will see how it is changing. This is the addition of drop by drop sodium hydroxide solution, and we will see the changes here. It is increasing now. So drop by drop addition, and here it is increasing. So final pH will be 5.8. It used to take time because it has to homogenate, mix properly. Every drop should mix properly in the medium, right? And then only it will. So here we have to keep patience because speed may disturb our medium making. If pH is not proper, if it is more than 5.8, the medium will be much more solid. So the availability of nutrients to the tissues or cells will not be available. If the pH is adjusting, we are adjusting below 5.8, then the solidification won't be there. Solidification won't be proper. That is why we have to add 5.8 only, so for proper solidification. This is the entire setup of pH adjustment. So now the pH is 5.8 exactly, and you can see here temperature also it is showing as 97.0. So since it's boiling, we have to boil it. So after boiling it used to around 5.7, so 5.8 actually exactly, and 97 or 200 degrees centigrade temperature. Temperature is important here. Both should be measured because when temperature is increasing, pH used to change when temperature increase or decrease. So now pH of the medium is adjusted. It's almost transparent medium. So this is the electrode. Electrode we have to wash properly with help of wash bottle. This is a glass bead. We have to wash it and keep separately because next time again we are going to use it. Electrode always we have to keep in distilled water in wet condition. It should not be dried. Then only it will give accurate reading. So pouring of the medium. Around 50 ml medium we are pouring in each bottle. So this is one commercial setup actually, just for demo purpose, how to make medium by use of ready-made media powder we are showing here. These are the lids we are going to use for after that we will autoclave it. So this is one small autoclave, and this, we are going to, so already medium water is boiling here, and this is the chamber where we are going to put our medium for autoclaving purpose. What is autoclave, what is the working principle of autoclave, I will show you in another video and another medium formation.